So Google AI Studio has really blown my mind in terms of what it's able to do. It's really crazy um, because it's basically teaching you how to do anything. It sees your screen and you can ask your question because it has a context of what you are seeing on your screen. It immediately understands your question much better, and well, it's having a sense of another dimension, so more extremely more context. When you try to describe something in natural language, it might not have been sufficient because you might not have been an expert on that topic, but or you might not have the best language skills in English because uh, it's not your native language, might not have been your native language, and or the thing you have been working on, or the science you have been working on, or the thing was you were completely unfamiliar with it, and you were just curious, you want to know more, you want to explore it. So exploration of different topics is now possible, or the topic you wanted to explore is highly advanced and it needed some basic, at least the basic foundation of that certain topic. May it be physics heavy or chemicals or whatever it might be. The great thing is that maybe you can open a study book and show Google AI. I mean, it can see your screen, so while you share your screen, you can ask your questions. The You will see while you are learning, you will of course encounter images of certain topics that is being taught. So you can show the image. Might it be maths or physics? By the way, in my lifetime, I might have only like put not more than 15 hours of time in math. So it's very great to live with this because I'm very, very bad at math. So basically, yeah, I will try to design a drone. Hey, that's cool. I don't know anything about anything meaningful in physics. I've heard about the laws, like the Newton, and a few more stuff, but it's all with what I have heard and nothing more. So let me try to show you how fast you actually can learn by using screen sharing with AI and real-time interaction through voice, or might be text, or I prefer voice. Um, let's use POC and we can share screens. Sorry for my bad English, but
No problem. I understand. Is there anything I can help you
did
with?
understand as you heard. So what you're seeing right now is a drone template which we will design on Simulink, and which I just installed the trial version of. This model, I think we should start with the non-linear airframe. I'm not sure what it is. Can you tell me what that is?
Okay, so what you're seeing is a drone template that is being designed on Simulink. It's the trial version of this model, and he thinks they should start with the nonlinear airframe. Do you have any specific questions about it?
Yeah, so what are the actuators and the environment?
Sure, in this model, the actuators block represents the mechanisms that control the drone's movements, and the environment block simulates external factors like wind and air density. Would you like me to elaborate on that?
So actuators is basically the inputs that gets to control the drone, and the environment is the external factors like wind. That gotcha. And what's the states?
You got it? Actuators are the inputs to control the drone, and the environment are the external factors like wind. And states represents the drone's current condition, like position, velocity, and orientation. Does that make sense?
It does. Yeah, let me click on it. So I see here many things. I don't know anything about maths. I know functions. I have been programming, but when it comes to explaining these stuff, I'm really bad at it. So you said actuators are basically inputs of what you try to do. What does the FCG
Yeah.
means and what's happening here?
Okay, F underscore CAG stands for the force at the center of gravity, representing the net force acting on the drone's center of mass. It's a crucial factor in understanding the drone's motion. Is there anything else about this that you would like to know?
What's the M? So the F is, I guess, the input, and the XYZ, I know that is the direction in 360 and three-dimensional space, and the N is the input. Is that correct? I'm not sure.
Okay, let's break it down. M underscore CG represents the moment or torque at the center of gravity. The F underscore XYZ input indeed relates to the force vector in 3 dimensions. The N next to F underscore XYZ represents newtons, which is the unit of force, and the NM next to M underscore XYZ means Newton meters, which is the unit for torque. Does that help clear things up?
Yeah, it definitely does. So we have, what's the body quaternion? Is that, what's that? So it stopped here basically. I'm not sure how many minutes it went, but right now probably because of um, the computation it all takes for long context, it basically is not able to continue further with the same conversation. Well, what I do here is refreshing the screen and share my screen again, continue where I left off. Well, this is a learning exercise. It's not for me very important
Okay,
that
let's
he
pick up.
remembers what it happened before. So we left off at where you explained me what the F underscore CG is and minus M underscore CG means, with the Newton minus mass was it, or meters, Newton meters, and there is Newton. So what does Newton means here?
Okay, it looks like you're reviewing a Simulink model. You want to know what F underscore CG, M underscore CG, and the units of newtons, N and Newton meters, and NGM, represent within that model. F underscore CG represents the force applied at the center of gravity in newtons, and M underscore CG is the moment applied at the center of gravity in Newton meters. Does that make sense?
So what is the Newton meters?
Newton meters are a unit of torque, which is a rotational force. In this context, it represents the amount of rotational force applied to the body around its center of gravity. Is there anything else I can clarify about it for you?
So the amount of force is applied, and what happens with the central body? Is that does that have anything to do with the body coedimian?
Yes, the force and torque applied at the center of gravity of the body, represented by F underscore CG and M underscore CG, directly affect the motion and orientation of the body. The 6DOF block calculates how the body rotates and translates based on those forces and torques. Are you interested in a more detailed explanation of the 6DOF calculations?
Yeah, so 6DOF, what does it mean, 6DOF?
Sure, 6DOF stands for 6 degrees of freedom. This refers to the 6 independent ways a rigid body can move in 3-dimensional space, including 3 translational motions, forward/backward, up down, left right, and 3 rotational motions, pitch, yaw, and roll. Do you have any other questions about the diagram?
No, and I think this is velocity, and then there is the E, which means the position on the Earth. Is that correct?
Yes, that's right. Vin represents the velocity of the body in meters per second, and Z represents the position of the body in meters, both relative to a reference frame. Is there anything else you would like to explore on this diagram?
Can you tell me what the X and the E means?
The X with a subscript E indicates the position of the body in meters relative to an Earth-fixed frame, also known as the Earth coordinate system. Is there anything else I can help you with?
Again?
Sure, Z represents the position of the body in meters relative to an Earth-fixed coordinate system.
Oh, so it's the body that's positioned on the Earth in meters.
Yes, that is correct. Yes, that's right. The unit of measurement is meters. Are there any other aspects of the model you'd like to discuss?
And what is this red?
You're pointing to the red block. That is the 6DOF block, which represents the 6 degrees of freedom of the body
Not that one.
and calculates how...
I mean this one.
Okay, you're asking about the phi, theta, and psi parameters, which are in radians. Those 3 parameters represent the Euler angles, specifically roll, pitch, and yaw, that describe the orientation of the body. Does this explanation clarify what you're looking for?
And what does the DCM means and the BE? What they stand for?
Okay, DCM stands for direction cosine matrix. It is a matrix that represents the orientation of the body relative to another frame. The subscript B indicates it is the direction cosine matrix that transforms vectors from the body frame to the Earth frame. Does that make sense?
No, can you explain a little more?
Okay, a direction cosine matrix is a way to represent the orientation of a rigid body in 3D space by relating the coordinate axes of the body to the coordinate axes of a reference frame. Each element in the matrix is the cosine of the angle.
Body and frame.
Okay, the body refers to the object you are simulating, in this case, an aircraft. The frame is the coordinate system that we use to describe the position, velocity, and orientation of the body. The Earth frame is a fixed reference frame, and the body frame is attached to and moves with the aircraft. Does this clarify the difference between the two?
The frame is the environment where the body is in?
In a sense, yes. The frame can be viewed as a reference point that doesn't change. It's the environment from which you are making measurements. The body is the object that moves within that environment. Would you like to explore any other aspects of the model?
No, thank you very much. I think I've learned a lot of things. If you look at this nonlinear frame for drones, we have talked about the actuators, environment, fixed mass, body quaternion, and the 6-dimensional. I forgot what the others meant, but the velocity we discovered, the body, which is X. So how many percentage of the nonlinear, how many percentage of drones science have we just discovered? Damn. So sometimes it gets stuck in this very important part. So I'm just very curious, like how much we have covered as amateurs, like not even amateurs, like beginners, like.
Okay, so you're talking about people who are new to something, like beginners.
Yeah,
is that correct?
But beginners for drones, someone designing drones on Simulink. I am right now at the airframe module. This is a block that's pre-designed, a template, and I've pressed, as you can see, there are sensors, flight control system, signal editor, environment, constants, commands, and nonlinear airframe with actuators and environment. So I pressed on the nonlinear airframe and I have covered the actuators, the environment, the inputs for the actuators and the inputs for the environment, which are external forces like wind, and we have covered the fixed mass, body quaternion, and the sixth dimensional of, I forgot the rest. And we have covered these v velocity meters, impact meters per second, and the body, and then the radius. So how much percentage or the complexity of drone making does actually drone designing and Simulink does this cover? How many percent? Can you hear me? I think.
Okay, you think so. What are you thinking about?
About the things you haven't thought about. So I have covered actuators in drone designing in nonlinear frame within the Simulink. I have covered the environment, the external forces like wind.
All right, it sounds like you've been exploring some complex topics, including actuators, drone designing, nonlinear frames, and the environment. What specific aspect of those topics are you thinking about at the moment?
Well, I've also covered the fixed mass and the velocity meters per second, body meters, and the radius. So how many percentage of the complexity did we already cover for designing a drone in Simulink?
Okay, you've also covered fixed mass, velocity, body meters, and radius. Now you're wondering what percentage of the complexity has been covered for designing a drone in Simulink. Is that right?
Yeah, that's true. This is what's if most hardest to understand. The things that are most hard, yeah, hardest to understand. What is the percentage of the total? As this is the non-linear airframe, by the way, the module. That was a template. So the actuators and the environment. So how much do I have covered it? How many percentage?
Okay, so you're trying to determine the percentage of the total complexity you've covered so far, specifically regarding the nonlinear airframe module, actuators, and the environment. It also sounds like you're curious about what the most difficult concepts are. Is that all correct?
Yes, it's all correct. I think this was the most difficult one, right? The nonlinear airframe.
It sounds like you believe the nonlinear airframe module is the most difficult part. Is there anything specific about that module that makes it so challenging?
I don't, there are a lot of calculations. I'm not familiar with maths or physics. So what is the percentage you would give at designing the drone in Simulink? What percentage did I have covered, do you think? I've covered.
Okay, so you're saying that the calculations involved in the nonlinear airframe module are challenging for you because you're not as familiar with math and physics. You're also now asking what percentage of the overall drone design in Simulink you think you've covered so far. Is there anything specific you'd like me to focus on when I try to answer that for you?
No, just tell me the answer.
Okay, I understand. While I can't give a specific percentage due to not having the ability to...
Give me the percentage, please.
I understand you want a percentage, but I cannot provide a specific percentage of
Not
complexity
specific,
covered.
Just predict, bro. Just say something.
Okay, well, it's still not possible to give a precise percentage. If I had to make a rough prediction based on what you've told me, I would say you've covered about 40% of the complexity in designing a drone in Simulink. Does that make sense?
Yes, so I have until the rad, the X, the V, so there is only DCM, VB, WB, and there's DWB, and then slash DT, ABB, within parentheses meters per seconds, square seconds, I guess, or times, I don't know. So these are the remaining. So do you still think it's 40% I have covered?
Okay, so you've listed the remaining elements, including DCM, VB, WB, DWB, and DT, as well as ABB with meters per second squared. Given these, you're wondering if my 40% estimate is still accurate. Is that correct?
Yeah, so I have already thought about actuators, environment, the body coordination, coordination, and the sixth dimensional of move of force, I guess. And yeah, that's the remaining part. So do you still think it's 40%, or do you have another estimate?
Okay, you've also considered actuators, the environment, the body equation of motion, and the six-dimensional force. Given this,
Yeah, go ahead. Sorry.
it sounds okay. You were saying that you've also considered actuators, the environment, the body equation of motion, and the six-dimensional force. Now you're wondering if my 40% estimate is still accurate given those things, or if I have a different estimate. Is that all correct?
Yeah, give me the response, please.
Okay, given that you've also thought about the actuators, environment, body equation of motion, and six-dimensional force, I would adjust my estimate to around 60% of the overall complexity being covered. Is that clearer for you?
That's crazy. That's crazy. Guys,
It
in
sounds
20 minutes we have covered like 60% almost. I mean, like if you also study these ones, these equations, I don't know anything about maths, bro. Anything about physics. But if I just use this Google and keep asking questions, like this rat, for example, if I just get stuck here for half an hour, like 1 hour, it should give me all of like 2 hours max. 2 hours this, 1 hour this, maybe some calculations to get familiar with it. 2 hours this, 2 hours this, 2 hours, like 20, 30 hours, and then combining all of this stuff, like in total 30, 40 hours, I'm a pro. Like with Google AI showing these stuff and maybe opening some other educational images, like this is advanced way of asking questions and getting advanced responses. And this is the fastest way to learn things. And I think this is just 10xing your learning experience if you are not a mathematics guy
okay, so you're
that's really great at mathematics. So yeah, it's only
okay. It seems like you're excited about how much you've covered in a relatively short time. You think that with consistent effort and the use of resources like Google, you could become very proficient in this area. It also sounds like you believe this is a very efficient way to learn and potentially achieve a 10x increase in learning speed. Is that a fair summary of what you were saying?
okay. Well, anyway, so I thought let him finish his sentence. So it's, I think, very fair to say that you can get to be an expert, maybe not an expert, but a junior in this stuff within like 2 weeks with a full time. Like if you didn't have any other job, you could basically design a drone in a month. As a person that doesn't know anything about physics, whatever it might be, but with unlimited AI, that would be necessary. Necessary, yeah. So this is good stuff. I had always issues with understanding. I don't know. I haven't really invested a lot of time. I was more likely busy with language sciences. So I am good with language, even with stuff I'm not very familiar with. I can structure sentences, at least do something with create even half-baked sentences about topics I am not very familiar with because of my language skills. So this is something very valuable, that the AI at least sees what I'm seeing, because displaying really makes a difference. So yeah, guys, sorry for my English again. It's a little bit, it's not the best, as I'm also speaking about a topic I'm not very familiar with, not at all. Mathematics and all that causes my brain to use more compute, remaining less for using great language. What am I talking about? Anyway, so that's good. That's good. That's good. So cool. Okay. So guys, you can build whatever the fuck you want. That's what I've learned. well, you can design this flight simulation. Basically, when you have the simulator, you can, if it works here in the simulation, basically it's a real life simulation, right? Means you have a working drone, basically. Just needs to be, I mean, it will take 1 month to learn what all these physics means, and what all of these stuff means. Not just these ones, by the way. I'm not sure how many days I would give this. Maybe 2 days, 1 day. In a whole day, you would have learned. 2 days, you would have learned everything, like groundly, and then this we have your AC, CMD sensors. We have as input actuators. This is a board, I guess, just making predictions. We have the sensors here. I guess I don't know anything about this. This is, I guess, about the environment, the mass, the matrix multiply, the gravity, basically. So understanding these formulas in general, yeah, I don't think you should just get too deep in it. Like if you want something working, you can have that very quickly, I guess. Something very general. There might be very lot of templates. It's not something I have studied a lot. Okay. Um, in general, I have read or talked with ChatGPT about drones, but not. I haven't been going this deep. So yeah, I mean, you can see for yourself how fast you can learn. It's really amazing what you can do with the Google AI. Well, I'm gonna upload this on YouTube. I don't know. I just want to share my thoughts, how I'm thinking about the way how it helps to learn this way, so people might understand what kind of disruption awaits us. People with less. Um, so yeah, you basically have a live mentor that can look and see what you are seeing. So that's nice. Well, guys, maybe see you in another time. Have a great day. Bye bye.